Right, so today we're going to take care of something that's called termination types. It's going to be slightly shorter than usual class, but not much. I also have, what do I have here? I have, just going to post that for you. Post it. What I mean by that is show you. We got some animals in the background there. It always comes through the microphone, man. Playlists. There we go. All right, so here is our class playlist, and when I keep going down with the items, again, the first part is the lectures, and the bottom part is the labs. All right, and yesterday's class is right here. Okay, that's our yesterday's class. So it's termination types, and I think I'm going to leave that one on, although we're still recording this one here. And on the bottom here, 1 and 2, you got fiber optics 1 and fiber optics 2 of 2. Okay, so please watch that. All right, and then when we see each other next time, whenever that might be, we're going to have a little discussion on that, just so you retain the information and the knowledge properly. Okay. Also, when it comes to fiber optics, we're going to, towards the end, we are going to have a lab. We're going to do a fusion splice of 2 single mode optical fibers using a fusion splicer. All right. Okay, so that's as far as the logistics that goes with that. And right now, we're going to take care of the termination types. All right, let's just start with some of the definitions. Gotta get this thing out of the way. Cable termination is, what is it? The connection of 2 wire or fiber, the connection of the wire. I wrote that and I can't even read it myself. Hey, it's one of these days. The connection of the wire or fiber to a device. So we're connecting something to something, to termination, such as an equipment, panels, or wall outlets. Right? Mouthful. Which allows for connection of the cable to other cables or devices. It's a termination. You have some kind of a loose cable, and you're terminating it as to something else in order to accomplish a proper connection between something and something else. All right. Now, you have done some termination types already. Like, for example, on your breadboard, when you're connecting like a hookup wire to the breadboard, you are actually connecting that. You're making a termination. So it's a temporary type of a termination. Nevertheless, it is a termination. Right? Now, just a little bit of synopsis on the IDC. All right. Okay, a bit of a history. Ready for it? In the early days, the connectors. In the early days of the connectors, 1940s, something around that, wires were generally soldered. And by far, soldering is probably the most reliable connection of wire to a wire to a component to a printed circuit board, and whatnot. It's pretty much the most reliable termination. The other one would be a crimp type of a connection. And also what we have done the screw type, screw terminal terminations. When we were during the last term, we have connected the cables, the electrical cables, to the duplex receptacles, right? But now we're concentrating on something that's called IDC, and IDC stands for Insulation Displacement Connection, or IDT, insulation displacement termination. But IDC seems to be the one that's kind of stuck forever. All right, so then came the crimp contacts. From the soldered came the crimp contacts that created gas-tight connections between wires and contacts by compressing the wire in a U-shaped portion of the contact. So here's a U-shaped portion. Here's a U. All right, you put a wire there and you crimp it. All right, so there's a crimp-on connection. Right? Crimping required stripping of the wire and placing it into a crimp machine one by one. So there goes the time idea, right? Time is money. Crimping has proven to be an extremely reliable wire termination method and remains the dominant form of termination of individual wires even today, again, besides soldering. Now, in 1959, a significant change in the industry was born when a pair of inventors patented the insulation displacement termination IDT or IDC, insulation displacement connection, right, of the wires to contacts, stimulating rapid innovation within the connector industry to take advantage of the cost and labor savings. So here's the main key idea, the cost and the labor savings. Most of us, there are a couple of groups that haven't done it yet. Well, actually you have done pretty much all of it right now, because we have done the punch down IDC. You have done it on the individual connectors already, so all of us have done it already. But the next lab, or this current lab that we're still doing, is the 25 pair cable termination. Can you imagine how much longer it would take to terminate all that 25 pair connector onto the 25 pair cable? Well, if you were doing soldering or crimping, soldering would involve stripping and basically doing all the prep that has to do with the soldering, and then we will have to solder them one by one. So 50 connectors, 25 pairs, 50 connectors. So the time that would take to do that would be significantly longer than doing the punch down IDC type of a connection. All right, same as crimping. Crimping also would involve stripping. So there's some extra prep work that is being done, and those conductors would have to be connected or crimped one by one. In some cases, things like that are still being done. Now, when it comes to IDC, sometimes you can do it and sometimes you can't. Like for example, when we are doing our infrastructure cabling or wiring, you can do this, no problem, because there is a termination there and it's nice and steady. There's no vibrations involved, like for example in a machinery, like some sort of electric motors running and sending the vibrations through the chassis that could wiggle the connection out of the connector, all right? Then in a car as well, right? So in a car, you would have either soldered or crimped type of connections. Mostly would be crimping connections in the car industry, right? However, in the cable infrastructure, when there is a steady building, there's no vibrations involved, huge vibrations, right? Well, if a train goes by not too far from there, that's not considered a huge vibration, right? So those things are quite reliable, and they are time saving. Those things are time saving. Also, when you do the IDC connections, you're able to compress the size of the connectors to the point that you can just punch them one by one, side by side, and you can have them close to each other. So you're also saving space. So time, labor, time, and the space is concerned. Now, when you're dealing with hundreds and hundreds of connections, when you're wiring a bigger building, then all that adds up. So the timing is basically, you're saving a lot of time doing this, right? So, and the bottom part of that, it has to do with the patent and so on. I'm not going to test you on that, just so you know. All right? Now, there's one thing that I'm going to point out to you. This is what the basic form of insulation displacement connection looks like. Here's a connector with some sort of a slot there, knife-shaped connector, and they are not spring-loaded, but they're pretty close to each other. So they can be separated a little bit upon pressure, but then they retain the memory and then come back to the original shape. So with the IDC, we don't strip the cable. Insulation is part of the, it's integral part of the whole undertaking, okay? So we are placing a conductor right on top of the connector, and you're using something to push it down, and it's called usually something that's called a punch down tool, right? You're pushing this thing in, the conductor in, the slot opens slightly and then it closes onto itself back again, and the connector is biting into the insulation, and it's biting through the insulation and it's making a contact with the conductor that's inside. IDC, so insulation displacement connection, right? Or insulation displacement termination. One thing on that picture I'm going to point out, and I was going to replace it with something else, but I decided to leave it on just so I can point out some of the wrong ways of doing things. Somebody, because I got this picture of the internet and there's a reference there in the posted lecture notes. This over here, you could see this is not a solid conductor, it's a stranded conductor. It's a stranded wire. This is a mistake. That's not a good thing. Right? And again, I didn't replace that because it gives me a chance to point this out. When you are pushing the conductor in, and this connector bites into the insulation, makes the contact, there's a chance that it could break some of the strands. Actually, there's a huge chance that it's going to break some of the strands. So for this reason, my computer wants to update. Not now. For this reason, the isolation or IDC, isolation displacement connection, should be done with solid conductors only. It's designed for that kind of a conductor. No stranded wires, solid wires, solid core. All right. And here's the reference to the picture here. And you have this thing already in the posted notes. All right, general overview. So presently, and I wrote this thing in 2020, so 2 years ago. Nothing has changed since then, trust me. Presently, the two most common punch-down platforms used in Canada and also in the United States, actually mostly in Canada right now we're talking about. I will tell you what else is available in the States. So presently, two most common punch-down platforms are used in Canada, and those platforms are 110 and BIX. 110, treat that number as a name. It's not because it has 110 of something and that's why it's called 110. No, it's basically a name. So it's a 110 type of a punch-down platform. And also we have the BIX. Now the BIX, whoever has had the opportunity to watch and the willingness to watch the preparation video for Lab 7, last lab, or actually this lab we're currently on, in order to watch the demonstration video, you would see on that video an extensive overview of what BIX is. And so if you haven't done so yet, please do it, okay? Now, the reason why I'm showing you those videos is not because I want to, I like to hear my voice or something and I want you to hear me talking. No, that's not the reason. The reason for that is that you are going to, well, there's a difference between going through a course and getting some lectures and maybe writing some tests and maybe performing some labs and getting the marks for it. That's one thing. You might get the mark for it, but you might not know what you're doing actually once you leave the school. What I'm aiming at is that once you leave the school, once you close the door for the last time for some period of time, hopefully you come back to do some additional training, then you're going to face the real world. And as you know, the more information you're going to get from me before that, the better you're going to be at, and the easier it's going to be for you to first find a job and then keep the job and be effective at the job. And there are two kinds of people, the good, bad, and ugly. There are two kinds of people in this world. Well, there are the ones who do the job and the ones who carry the tools for the people who do the job. So, well, you decide which one you want to be. All right, so that's why. Okay, so yeah, please watch that video, and you're welcome to rewatch it again and again and again, even after you leave the school. If you end up working in the telecommunications industry, and the telecommunications in the traditional understanding of that word, of that trade, would be dealing with radios, antennas, and whatnot. So that would be the original telecommunications part of the industry. What we're talking here is the infrastructure cabling. So it's also telecommunications, but it's kind of like evolved. I call it the modern type of telecommunications. So network infrastructure, networking and infrastructure is a huge part of that. As I keep saying over and over again, you can't imagine a building existing, a commercial building, without the plumbing, without the electrical works. And right now, you can't imagine a commercial building, and even a residential, without some sort of a network. It's not happening these days. Right? So the jobs are there. There's a lot of jobs, and there are new installations, there are service calls, there are modifications, retrofits, and whatnot. You can be as busy as you want if you master enough. Master, I use that term loosely. If you're comfortable with that, and the more you know, the better you're going to be, and the more employable you're going to be. Right? All right, so here's the thing. Okay, so let me read it again. If you end up working in the telecommunications industry, you will also see something that's called 66 blocks. And again, 66 is the name of a punch-down platform as part of the existing or old installations in Canada. Right? In the States, if you end up working in the States, you're going to see some of the new installations using also 66 blocks. So when it comes to Canada, for the most part, you're going to see 110 and BICs. And in the States, you would see something like 110 and 66 blocks. Although BICs is becoming more and more popular in the States when it comes to POTS terminations. However, when POTS are being phased out, you're going to see less and less of that, both in Canada and in the United States. You're going to see less BICs in Canada, and you're going to see less 66 and BICs altogether in the States. However, there are a lot of systems that are still in place, and you're going to be sent to service them, modify them, retrofit them, and whatnot. So it's extremely important that you know what this whole thing is all about. Right? So the 66 system is still widely used in the USA. So if you get an installation contract from a company located south of the border, because the States is south of us, right, you might find 66 blocks shipped to you. What I mean by this, right? There are huge companies that provide an umbrella coverage over United States and Canada as well. Like, for example, there's a company called Bailiwick, and they're in Minnesota, and they provide the IT services for all the Home Depots, right? All the Dollar Trees, and there are a lot of other smaller chain companies, but Home Depots and Dollar Trees are huge for companies called Bailiwick. There's also Canadian companies like CompuServe. And CompuServe, they changed the name. I think they're still called CompuServe. They're a Canadian company that the umbrella cover all the IT services for all the Tim Hortons restaurants. Right? There are some other companies that so there are big companies that cover the services for that. So when you get a contract to service one of the departments like Home Depot or something, or maybe a Dollar Tree or something like that, if it's a new installation, you're going to have all the equipment shipped on the skids to you, right? With a couple of manuals about this thick, right? There's one manual this thick, and there's another manual this thick, and it all has to do with the installation of that particular system. Now, you are going to have to read only once, because if you repeat the installations, you're just going to use those manuals as reference for certain details. But if it's a first-time installation for you, well, sometimes some of us we're struggling with watching some of the videos that I have presented, and some of the videos were long enough to cause some whatever. But it will be like a 1.5 hour video. Okay, so it's an hour and a half. Okay, well, when you get to the real world, you get the installation manual that you're going to, they're going to have to install starting next week, and you're getting those manuals on Thursday night shipped to you. So, well, there goes your weekend, right? Because Friday you still have to put a full day of work, and there goes your weekend for reading those two thick manuals like that. So so it's not an hour and a half. The whole weekend goes. It doesn't happen all the time, but it does happen. All right. So get ready for it. Okay. Sip of coffee. All right. So sometimes when you get the equipment shipped to you, you're going to have all the connections, all the wires, all the screws, bolts and nuts, and everything that has to do with that is going to be all packaged and shipped right to you. And when it comes to having to connect some sort of telecommunication wiring as POTS lines or some other control wires that involve that IDC type of connection. If it's a company from the States, you're going to find those 66 blocks in there. Right? So here's the thing that I wrote. You can decide what to do with it. In Canada, from my experience, what we have done, the most common practice would be recycling the 66 block and replacing it with the BICS system. And never mind. Okay. So that would be the thing. All right. Now, if it's a Canadian company, then chances are that you're going to have a BICS block or BICS platform shipped to you. All right. Here's the statement: there are many punch-down platforms. In this world, there are many stories, and this one is mine. It's from one of the movies. Okay, there are many punch-down platforms. The shapes and forms might vary, but the purpose is one. It's to organize the field wiring in a permanent and systematic way. I'm going to read it and I'm going to explain this to you. So it can be so it can be easy to cross-connect various points of the cabling structure. Physically, permanent cabling structure makes it possible for the cable runs to be tested and certified. This way, cross-connecting changes will not affect the physical structure of the permanently installed cabling. What I mean by this, what does this mean? So here's a part of the building. Let's see, there's a watered down version of a building, huge building, 200 feet or whatever, right? And there's a termination panel right here. And there's a termination panel right here. Let's say this is some sort of a main communications room right here. Okay, so there will be terminated. All the wires from the outside come here and they get terminated. And there will be another panel here that would involve the field wiring, or maybe some of the wires would run up in the wall, through the ceiling, come back in the wall, and come back here. Right? So, what can you do? You could just how many lines or how many circuits you need for that. You would just say, okay, we need about 60 cables. So you'll put 60 cables, 4 pairs each. Or you can get something that's called 25 pair cable, and you can just put one cable, whichever you want to do. And of course, how would you connect that? Would you just twist them and put some morettes on them? No, right? Because you could create a huge mess here and huge mess here, and this thing would be so unreliable because anytime somebody would come over there and mess with the bundle, touch the bundle, you don't know what has changed by you touching it. So it would be not very reliable as far as guaranteeing or keeping the specifications of those cables and the connections of those cables, right? So when we do those terminations like that, we're making them permanent, right? So we are permanently mounting those cables here, and once they are mounted, they stay. It's almost like solidified. It's not really solidified, but they stay. Nobody touches them. Okay, and they're permanently mounted in the ceiling through the walls, and they're permanently mounted here. So if it's a permanent termination here, then you can plug in your tester and plug in your remote device from the tester to each and every termination or pair or whatever, the outlet or jack, and you can perform a test, and you can save the test results, and you can present them to the client. A lot of clients request the test results for every connection that they make, and they keep it on file. So now, if you have another device there, so this would be a patch panel, and this would be a switch or something like that. You could use those portable patch cables to connect those. So you're making changes here, but you're not making changes in the permanent installation, right? So let's go back to the previous slide. Here. The shapes and the form of purposes one, to organize and fill wiring in a systematic way. So we just explained that right now. So it can be easy to cross connect, to do the cross connections, okay? Physically permanent cabling structure makes it possible for the cables to be tested and certified. This way, cross-connecting changes, whenever you're mucking around with those, it doesn't affect the permanent structure. Okay, so that's the idea of this whole thing. Yeah. Yeah. Right, let's just take a look at some of the punch-down platforms that we're going to be using, or we're using, that are basically implemented in the industry. This is the BIX. Right? BIX punch-down platform. This is what the BIX head looks like, punch-down head. It does have the element that pushes the connector into the isolation displacement connector, and it does have a knife. In the BIX, this is the shape of the punch-down tool, and this is the shape of the knife, and the knife is it's a moving part. It moves. Once you punch it, there's a certain mechanism there that makes the knife go across that and just cuts the wire off. Right? So in this case, when you have those conductors inserted into those connectors, you put in the punch down tool right here. It pushes the conductor inside the IDC, and it cuts off the unused part of it, and you get a nice and beautiful and clean installation that way. Right? So that's what the BIX punch-down platform looks like. Right? Here's 110. As opposed to the moving knife in the BIX, 110 has a nice and molded-in stationary knife. It just pushes down, and by the push-down action, the conductor is being cut off. So that's what it looks like. Now, the shape is a little bit different. Same, the idea is still the same, but because of the connector has a different shape, so does the punch-down tool. It also has a different shape. When we are using the BIX platform for connecting, we should use the BIX punch-down tool. If we are using 110, we should use the 110 punch-down tool. No ifs, ands, and buts. Okay? And basically that's what the more or less, because there are different the connectors come in different shapes, but that's basically what the punch-down action looks like when we're using 110. The conductor here is being pushed down, and the knife, which is on the other side, is going to cut off the remaining part of the wire. Again, those platforms are not interchangeable. And here's what the 66 block looks like. If you noticed, next time you're around in the lab, look at where the little 616 Meridian telephone system is mounted, right by the cage, where the equipment is locked. Right on the outside of the cage, there's a phone system that's installed, and there's a BIX platform, and right beside it, I have screwed on, just mounted, the 66 block. That's basically what it looks like. What it looks like over here, these are the IDC connectors. Right? So this is 25 pair. Each conductor has its own row. So a pair of that, blue and white blue, for example, this would be a white blue row, and this would be the solid blue row. And the next one would be white orange row, and a solid orange row. So if you want to connect two cables with 4 pairs, let's say you just want to connect this one pair, you punch it into those 2 slots. The top one right here would be the white blue, for example, and the bottom would be the solid blue. So the white blue would be carried on. If you want to butt into it, you would just put another cable into this one or that one or that one. Okay, so this will be the same connection for another wire from the other side, and the other connector for the conductor for the same pair, you would use the bottom row. All right. All right. So now there are 2 types of those 66 blocks configurations, and sometimes you're gonna have to figure them one by one. Some of them would have this whole row connected to itself, and this one connected all to itself, and this one, and so on. Some of them have a split kind of a connection. So these 2 are connected to each other, these 2 connectors, and these 2 connectors are connected to each other. And there's a break in between. And in those cases, you get those 66 clips that you just clip onto these in order to make the connection. And this is what the 66 punch down tool looks like. Now the pros and cons. Well, the 66 blocks takes a little bit longer to terminate. There's a little bit more mucking around with it. The cable management it can be a little bit more tricky than the big punch down that we have done with the 25 pair. So you have to pay more attention to the cable management. Everything has to be nice and neat. However, if you don't have a punch down tool and if you just want to make 1 or 2 connections, you can get by with needle nose pliers. Just push those in. And it's a secret, right? I didn't tell you that. Technically, you shouldn't be using that, but it has been done. But that's what the 66 punch down tool looks like, and that's what the 66 block looks like. Right? Now the third one I'm going to show you is the cron type. The cron type, I haven't mentioned that before today. You can see that mostly in Europe and in UK. Right? So mostly you're going to see that in England or in Great Britain, and some of it in the rest of the Europe, right, in the mainland of Europe. You will not see that pretty much here in North American continent. However, I want you to know that something like that exists. And this is the cron punch down platform. That's what it looks like. And this is what the cron punch down tool looks like. Also has a moving knife. The punch down tool is a little bit different. The only thing that I can tell you about the cron punch down platform is that when it comes to bigs and 110, 1 connector per conductor, right? If there's 1 connector, you just put 1 connector in, punch it in, and that stays. You can't double them up, because if you put one on top of the other, that V-shaped knife kind of a connector is going to expand a little bit more on the top or on the bottom, and the top part is not going to make as good a connection as the bottom one because of the shape of this of the connector. All right, just like that here and here. All right, so you can see what's going on here. Now with cron is designed in a way that you can stack 1, 2, and sometimes maybe even 3, but I could be wrong. I think I haven't used much of that cron thing, but it does exist. Now here is the example of the BIGS termination platform. So over here of the BIGS termination field, right? So you would have the cables coming from outside. And there would be all this circuitry that turns those lights on and off. Excuse me, that's the distribution panel there. And those wires, those cables are terminated on the BIGS field. We only terminated one during our lab, but of course they are designed so the whole thing can be filled up. That's why neatness and proper wire management, cable management comes in play to that, because if you're messy with that, you're just going to paint yourself into a corner that you won't be able to stick any more wires in there. So neatness is important. They're here terminated, and maybe the field wiring is terminated also on another BICS field. All right. So now this is terminated on that. Remember, we punch them from the front, and then we flip it upside down. So the terminated wires are on the back end of the connector, and the slots that are free to grab those pairs from the front are at the front. And the same thing we do with the field wiring. And then we use something that's called a cross-connect wire. Once everything is terminated here and left alone, and everything is terminated here and left alone, then if you want to connect this pair to, let's say, that pair right here, or whatever, so you would just go and get the cross-connect cable, which is basically one pair of wires on a reel, and you would punch them down from the front. You would neatly run them in through here, through the cable management rings, make a loop, and come down right to where it's supposed to be and punch it here. Right? So sometimes those things can be pretty much filled up like that. So that's the idea of the cross-connecting of the BICS. All right. Now, 110, mostly you're going to see the terminations on the jacks and patch panels. So on the jacks, there'll be a wall jack, single jack, terminated on the wall, mounted on the faceplate, and mounted to the wall. And in the patch panel side, everything home runs to the patch panels, and that's what they look like. So that's basically 110 termination. That's what it looks like. So mostly the BICS would be used for POTS lines and some control wiring. However, there are available on the market, not as popular, but still available, Cat5e type of BICS connectors. The ones that we are using, they are Cat3 rated. These are for POTS lines. You can get BICS termination blocks in Cat5e version. Well, whatever you need to use, depending on the purpose of the whole system, you buy the appropriate equipment. But 110 mostly is going to be used in data termination, Ethernet. 66, that's what 66 termination looks like, right? So this here, all this termination, see how much more space the 66 block looks like? It's a whole big room. I took that picture in one of the bigger facilities in GTA that I had to do a service call. So I just thought, this thing looks so neat and so old and so sentimental. So I gotta take a picture of that, right? So this whole thing can be replaced, well, with basically a little bit more space than that. You see how much less space those things take, the BICS, as opposed to the 66. Oops. Yeah, 66 blocks. All right. Nevertheless, that's what it looks like. This service call that I had, that was years and years ago, I had to move one store from in the big mall across the hallway. Now, when I had to do that, I had to tone the connection. So can't run in the big mall, can't run a cable across the hallway because the ceiling is big and the ceiling is high and the floor is quite concrete. So you have to go down right to the communications room to see where those cables are coming in, and this will be the main communications room in that mall. So I had to stick a toner, and I'll show you that in further lectures what the toner looks like. I would stick a toner into the tone generator into the outlet, the telephone outlet where the existing store was, and I would take 10 minutes to walk down to the basement and look where the communications room is, and I would just run my probe to see where the tone could be possibly sounding. So I would zero down to the area, and then I would pretty much make my way to right to where the pair was, and I have made couple of marks with the electrical tape, and I wrote down what it is, because It was a renovation. I had to switch that store from one location to another, and then 2 months later I had to come back and switch it back. All right. So the other side, the other wires from the other store would just, I think, would be somewhere on the other side. Well, it looks kind of intimidating because you walk in there, oh, there's so many wires, blah, blah. You know, if you just look at the whole thing, yeah, you're gonna get dizzy from looking at all those wires. But now, when I'm telling you all this, it becomes less and less intimidating because even though there's a whole bunch of wires, but you're looking for the one that you're looking for, right? And you're looking for a pair, and a pair is supposed to be terminated on the 66 block in this way. In this way. So that huge room was just a lot of these, all right? So I hope it looks less intimidating to you right now, all right? And okay, so this is the last slide for this lesson. I'll just give you some idea of what types of terminations we have. So we have covered the BICS type of termination, and all of them are IDC, Insulation Displacement Connection. We covered BICS, we covered 110, we covered 66, and these will be the three that you will be dealing with. And we have also covered cron, just so you know that this exists. And if you're going to stay within the North American environment, you probably won't see the cron ones. But if you ever get yourself a job somewhere in Europe, you might. Yeah. Okay, guys. So this is pretty much it for today. Again, on that YouTube playlist, watch those optical fiber ones, those 2 lessons there. And when we come back, we're going to take a look at maybe answer some questions and whatnot. We're going to have a little bit of discussion. And just to put a stamp on that fiber optic kind of a thing, the idea, we're going to actually touch those fiber optics, we're going to strip them, we're going to prepare them, and we're going to put them in the fusion splicer machine, and we're going to close the flap, push the button, and the thing is going to provide a spark that is going to fusion splice 2 pieces of fiber optics together, and it's going to make it one. Okay? Thank you very much, guys, and have a great one. And as I always say, I'll see you when I see you, hopefully sooner than later. Okay? Bye.